Again, good morning, everyone. We are now in the introductory lesson for Science 10. Okay, the Earth's natural processes. What do you think are the Earth's natural processes? Any idea? Before we start, any questions before we start? Grade 10.
The natural disasters are like floods, earthquakes.
Yes. Yes. What else? Those are natural processes. What else? The formation of your volcano, number 1. The formation of your mountains, number 2. Volcanic eruptions, number 3. So those are the natural processes. Let's take a look at how these are actually formed and what are the effects of this, right? Let's start with volcanoes. Okay, Earth's lithosphere is broken into several tectonic plate segments of Earth's crust that are extremely slow motion. So you can actually cannot feel as of the moment, but the tectonic plates are moving. Okay. Most volcanoes can be found in areas where tectonic plates are located. Okay. Other volcanoes can be found in clusters in small areas. Some geologists estimate the number of active and extinct volcanoes to be 100,000 all in all. See, if you're going to look at it, it's 100,000. So scattered all over the earth. Meaning to say that these will give you an idea that the plates are really moving. Okay, if there is a volcanic eruption, tendency is the pyroclastic materials are actually moving towards the surface of the earth, which causes movement. Right? Most active volcanoes are located in 2 volcanic belts. Okay, the Alpine Himalayan belt and the circumbelt, also known as the Pacific Ring of Fire or Ring of Fire. Okay, the Rings of Fire or the Ring of Fire, which outlines the major trenches in the Pacific Ocean, is an active volcanic and earthquake area. Why do you think so? What do you think are the reason why there are a lot of active volcanoes in the Alpine Himalayan and the Pacific Ring of Fire or Ring of Fire? What's with the Ring of Fire? What's with it beneath? Any idea?
What was the question, sir? You were a bit choppy.
Okay. Again, most active volcanoes are located in Alpine Himalayan and the Pacific Ring of Fire. Okay, what do you think are the reason why these volcanoes are actually located in those areas? Am I choppy?
Not anymore, sir.
All right. So if you're going to analyze, you need to think about what are in these areas, the Alpine Himalayan and the Ring of Fire. We are actually located in the Ring of Fire. Okay, we are actually located in the Ring of Fire. We also know that one as the Pacific Ring of Fire. Okay. The Marianas Trench are also located in the Pacific Ring of Fire. Okay, in the Pacific Ocean. And scientists believe that the Pacific Ocean until now is still spreading its surface. Okay. The question there is, why do volcanoes or most active volcanoes are located in the Alpine Himalayan and the Pacific Ring of Fire? What do you think are the reasons? Any idea? Grade 10? Margie, could you still hear me? Any idea? Well, talking about the Himalayan belt or Alpine Himalayan belt and the Ring of Fire, these are the areas where pyroclastic flows or pyroclastic materials are actually moving towards the surface of the earth. Okay. Remember that beneath the earth contains a lot of pressure, and this pressure should be released in the surface, right? And in this area, in the Ring of Fire and in the Alpine Himalayan, are areas for what? Areas for
Volcanic and earthquake.
if there's an earthquake, sometimes there are a lot of cases that the cause is tectonic and the cause are volcanic eruptions, right? Now, talking about the Ring of Fire and the Pacific and the Himalayan belt, this is the area where pressure is released. Okay. The volcanic eruption are the pressure released by the pyroclastic materials underneath the earth, right? Again,
Yes.
underneath the earth, there are some building up of pressure of the pyroclastic materials. It needs to be released, and it can be released in the Ring of Fire and the Pacific and the Alpine Himalayan belt. Because these areas are open, these areas contains also a lot of active volcanoes. Okay, if you have question, please let me know so that I can address your concerns. The Alpine Himalayan belt reveals the collision of the African and Indo-Australian plate with the southern margin of Eurasian plate. This belt extends from the Mediterranean area eastward through the Turkey and Middle East, north of India, and into the Indonesian islands. Let's tackle this later, right? We have a layout. Scientists already layouted the areas where active volcanoes are located and their volcanic activity. Okay. It contains the volcanoes of Sicily from Italy, the Aegean Sea, Asia Minor, okay, the Indian Ocean, the Southeast Asia, and the Indonesia. Sure. Can we see the layout? Okay, I will let you see the layout later. The Ring of Fire has many of the world's active volcanoes, including in the New Zealand, Papua New Guinea, Philippines, Japan, the Kamchatka, okay, Peninsula of Russia, Alaska, the western region of the United States, the Central America, the western region of South America, and the numerous volcanic Pacific islands scattered between the bodies of these lands. Okay. The locations of volcanoes are associated with tectonic activities. If there are some tectonic activities, like just what I'm telling you a while ago, there are a lot of volcanoes scattered there. Okay. Mount St. Helens in Washington and Mount Pinatubo in Philippines are two known dangerous volcanoes. Okay, are located on the plate that are grinding together. Okay, there are some collisions happening there. Let's take a look at or discuss later the collisions, right? Other volcanic islands seem to rise in the middle of tectonic plates. These volcanoes can be found in the Iceland and in the Hawaiian Islands. So far, questions?
No answer.
Okay, this is the Pacific Ring of Fire. Okay, we're going to look at it. It actually encircles the what? The Pacific Ocean. Okay. The Philippine Trench, the Marianas Trench is in here. Okay. Mount Pinatubo is in here. This is the Philippines. Okay. Right? We belong actually in the Pacific Ring of Fire. Okay. Krakatoa, Japan, St. Helens. Okay. And there you go. Right? If you're going to analyze the picture here, what do you think are the reason why this area here, this one, the Pacific Ocean, is wide. Sure, is that wide? Of course, that is really wide. Okay, since these are active volcanoes, and this actually contains a lot of volcano or volcanic activity, tendency is in the sea floor also, we have a lot of sea mounts. These sea mounts erupt in their own, and afterwards causes now the sea floor spreading. Okay, this is one reason why the sea floor spreads all throughout, right? This is the reason also why, are you familiar with Pangaea? Pangaea? Okay. This is the reason also why Pangaea is actually or are broken down into pieces. Okay. This is the reason why, right? Are you still with me? I have only Hal here, my student. The rest don't have camera. I understand, Margie, but the rest, I don't know. Margie's advisor already discussed about this to me. The rest, I don't know. Okay, again, you need to use your camera. Active volcanoes are usually associated with earthquake activity. If there are some volcanic activity, there is always an earthquake activity. It is really associated. They are really associated. Okay. Presence of hot water springs and changes in the elevation of volcanoes crater. An active volcano may erupt at any time. Okay. Some volcanoes are considered dormant. Dormant meaning to say it's not moving. It don't have volcanic activity yet, but there are some possibility that it will erupt because they have no unknown history of eruption but may erupt based on the seismic or seismic indications of tectonic activity beneath the volcano. Volcanoes that have no known record of eruption and tectonic activity for a long period of time are called extinct volcanoes. Okay. Again, if you have questions, please raise it, and I will entertain question anytime. Right? Magma and volcanism. The Earth's internal heat is essential in sustaining life on Earth as it drives most geological processes, including volcanism and plate tectonics. The source of heat attributed leftover heat from the formation around 4.5 gigaannum. Okay, gigaannum meaning to say these are the what? These would illustrate us the period. Okay, as gravitational energy cause particles to accrete and collide with one another, forming larger bodies. It includes the collision of Earth and Theia. Scientists believe that Earth actually collides with Theia. This is a planet long time ago before that actually bumps in to Earth, okay, which lead to the formation of Moon and differentiated Earth. Okay, because of this, heat is trapped on Earth, and because of this heat, a lot of organisms survived. Okay. Another source of Earth's internal heat is the disintegration of natural radioactive elements inside Earth, such as the radioactive decay of uranium, that's 238, thorium, that's 232, and of course the potassium. Based on geophysical data and geochemical models, scientists estimated that the temperatures in Earth's core is between 5,000 degrees Celsius and 7,000 degrees Celsius. We cannot actually measure it directly. Okay, but these are the estimation based on the radioactive decay. Okay. Do you have any questions so far?
None so far, sir.
Okay. Advancement of technologies also dependent on these, okay? These data, right? Because these are also the basic foundation of those technologies, right? Magma, okay? Rocks commonly found on the surface of the earth are solid state. However, rocks also exist in liquid state at certain locations deep inside the earth. Okay, the molten rocks are found beneath the earth's surface are called magma. Okay, when you're talking about magma also, if it is still inside the earth's mantle or inside the earth's core or inside the earth's crust, it is called magma. But if it emerges to the surface, it is called lava. Do not be confused. Okay. Sometimes also magma cannot actually go out in the surface and left cooled inside the chamber or the magma chamber. So still, those are magma, right? Molten rocks that are found beneath the Earth's surface are called magma. They are less dense than the surrounding solid rocks and therefore capable of rising to the surface. Again, the one I'm telling you a while ago, when magma emerges to the surface, it is called lava. Magma is usually composed of abundant elements including silicon, aluminum, iron, calcium, magnesium, sodium, potassium, hydrogen, and oxygen. Okay? The compositional variation of magma is expressed in terms of oxides. Like for example, silicon oxide, aluminum oxide, calcium oxide, magnesium oxide, ferric oxide, okay, and water. Okay, the most common component is the silicon or silicon oxide at 45% to 75 by weight. Silica. Okay. These are the composition. Take note of the composition. Right. Dissolved gases, primarily water vapor and carbon dioxide, are also present, comprising 2.2 to 3% by weight. Right. Another property of magma is that it has a very high temperature. Okay. The melting temperature of rocks could range to 800 degrees Celsius to 1,400 degrees Celsius. Again, what is the boiling point of water?
100 degrees Celsius.
100 degrees Celsius. This is 8 times to 14 times, right? The temperature is 8
What, sir?
times. What is the boiling point of water? According to Holly, it's 100 degrees Celsius. Okay. So magma magma melting temperature is 8 times, if you're going, because this is 800 degrees Celsius, to 14 times the boiling point of
Okay.
water. That is the comparison. Magma also has the ability to flow since it is liquid. Okay, the degree of resistance to flow is called viscosity. Viscous. Okay, viscous, meaning to say lapot. Okay, sticky. That's viscosity. The more viscous the substance is, the less fluid it becomes. The less movement. Okay, the viscosity of magma generally depends on its silica content. Okay, magmas with high silica or silicon are more viscous than low silica magmas. Gas content and temperature also affect the viscosity of magma. Viscous or the stickiness. Do you have any questions so far? Questions so far? Okay.
Sir.
Generally, gas content is higher when temperature is higher. Okay? And this makes magma less viscous. For instance, lava just came out of a volcano, has a very high temperature and flows readily. But the temperature decreases. It becomes more viscous and eventually stop flowing. Okay. So if you're going to observe this one, you can actually observe the domes. Okay, because it flows slowly, it forms now the domes. Okay, let's take a look at later. What are those? Okay, it's okay. Formation of magma. Magmas are formed under circumstances in special locations, deep in the crusts in the upper mantle. They are formed when conditions are right to cause pre-existing solid rocks to melt. The common notion that the crust floats over the sea of molten rocks is wrong because mantle is most solid. Again, mantle is mostly solid. Beneath mantle, you can actually see the pyroplastic materials or the magma. Right? Questions? Questions so far? Question? I want you to ask
Answer.
questions. Yes. It's almost time. Magma can be generated in several ways. Okay. Melting can occur when the temperature stays the same, but the pressure decreases. This process is called decompression melting. Again, decompression melting happens when a magma generated in magma's temperature stays the same, but the pressure decreases. Again, magma's temperature stays the same, but the pressure decreases. This is decompression melting. This usually occurs in parts of the crusts called the rift valleys, mid-ocean ridges, and the volcanic hotspots. Okay? Your hot springs. Okay? There are some decompression melting there happening. Okay, what are pyroplastic materials again? Pyroplastic materials, these are the components of your magma. And these are pyroplastic materials, right? Again, these are molten rocks with a lot of elements. Okay? And these plays a vital role in your volcanic eruption. Okay, so this is the illustration, okay, of how your magma actually flows. Okay, the subduction plate is in here, flux melting. Okay, the volcanic hotspots, and it is in circular motion. Sure, why circular motion? They're actually looking for spots because these are pressure, built up pressure underneath the Earth's surface. So they're looking for spots that they can release the pressure. That is why usually they observe, or scientists observe, that these components are actually in the Pacific Ring of Fire.
So, sir, the eruption will just stop. Nothing like, wala mo cover, sir ba?
Yes, yes. You cannot actually stop it over unless all the pressure is released. Okay. Again, these are not just in the volcano. Okay. We have trenches also. Okay. We have seafloor spreading. We have volcanic mounts. Volcanic mounts are volcanoes in the ocean floor. Okay. There is a question before. It is actually asked in a quiz bowl that can we consider again the sun the ultimate source of energy? Diba in our lessons, sun is the ultimate source of energy, correct? Okay, that is before. Now, sun is a one source of energy only because scientists actually found seamounts, and in the seamounts, they actually observe a lot of bacteria living there, which did not use or did not consume the animals and plants. Okay, they are just eating the chemicals in the seamounts. Yes, MD, it's okay. So it is called what? The process of creating food out of chemicals, it is called chemosynthesis. Okay. If it is photosynthesis, this is the process of plants creating their own food. Okay. But because of the discovery of the seamounts underneath the seafloor, they found out that there are a lot of bacteria living there and consuming the chemicals in the seamounts. They're actually performing chemosynthesis. That is why the sun now is not the ultimate source of energy. It is one source of energy because there are a lot of organisms also consuming chemicals for their metabolic processes. Right? Do you have any questions so far? I think that will do it for today. Let's continue by next meeting. We are done with the introductory and hopefully you can participate in our discussion. You can also do the research first. You can download the modules. The modules are already in your LMS. Sir, we are online. Yes, you are online, but you need to download the modules because those are your notes, right? You check on the notes, and in order for you also to answer some questions, right? Because I'll be throwing questions every now and then, and I want you to participate with those. Your prior knowledge, I need to assess your prior knowledge if you understand the lesson and if you have also a prior knowledge of the lesson, because these are discussed in your previous years, right? And this is considered as an enhancement. That is why, sure, why it's broader than the previous years. This is broader than the previous years because this is considered as enhancement to enhance your learning. And aside from that, I am preparing you for senior high and college. You'll be dealing with this also in the senior high and college. In fact, you will have a subject called earth science in senior high. Okay, for STEM, earth science. For ABM, gas and UMS, you will have earth and life science. Still the same, you will have earth science. So at least you have already the idea. By the way, this is not just for the lesson alone, right? This is for you. You paid for this. Okay, that is why this is not for lesson alone. You need to live with your lessons. You need to use this one in your daily life. Right? Because if you're going to memorize this one, the lithosphere, asthenosphere, the movement of this magma, you will find it hard. All you have to do is to familiarize. And once you are familiar with these terminologies, it will just come in your mind while discussing. Okay? This is also one way to understand the concepts of science. I already discussed this with MD and Margie before, when we were still having the Science 9, that the lessons or scientific knowledge are just concepts, so you need to familiarize them rather than memorizing them. Okay, even when you're having if you're going to take also the medical courses or nursing, for example, you need to familiarize because there are a lot of concepts there. You cannot just have them memorized. Familiarize and associate things over. That's how we learn. Okay, that's how humans learn. Familiarization and association. You need to associate. Okay, this is associated with the Marianas Trench. This is associated with volcanic eruption. Shield volcano is associated with this and that. And there's it. Hopefully, you learn something out of our simple discussion. These are just introductory because you've already been discussing this one for a long period of time in your previous years. Right? And I think that will do it for today, class. If you have questions, just raise it in our GC or you can ask directly to me. Okay, I'm open to that. Right? If you have problems with your lesson, please let me know. Okay, just
sir.
like MD and Margie before, they usually contact me if there are some questions with the lesson. Right? I think that'll do for today, class. Thank you for your participation, grade 10. Have a nice day, everyone. Goodbye.
Thank you, sir. Bye.
Thank you.
Bye. Thank you,
Bye-bye.
sir.
Take care and enjoy your day.